Hi Year 10, this is our new topic of non-linear relationships. I've split this topic into two. So firstly we're going to look at parabolas and then we're going to look at other non-linear relationships. So let's start by reviewing linear relationships. Remember, a linear relationship is a straight line. It goes up or down by the same amount for every horizontal step we take. So as I go across one, in this case I go up 2. Go across another one, I go up 2 and it stays the same. Remember, this is called the gradient of the line. Now we can pick a linear relationship because it's only going to have a term in x and it's actually going to look like y equals mx plus b, which you should be familiar with. A nonlinear relationship is not a straight line, it's a curve. So here's some nonlinear relationships. Y equals x cubed, y equals 1 on x, or y equals negative the square root of x. Now, a quadratic relationship is one of those nonlinear relationships. Let's have a look at this. As I go along, it goes up 1, go along again, it goes up 3, go along again, it goes up 5. So it goes up or down by an increasing amount for each horizontal step. And it's going to have a term in x squared. Now we can complete a table of values for a quadratic relationship just by substituting in values for x. So let's complete a table of values for y equals 2x squared, take away 1. I'm going to start at 0, so I'm going to substitute this 0 in because it's the easiest. 2 times 0 is 0, take away 1 is negative 1. And now I'm going to do the positive values. Put the 1 in, 2 times 1 squared is 2, take 1 is 1. Put the 2 in. 2 times 2 squared is 8, take away 1 is 7. And then finally put the 3 in. 2 times 3 squared is 18, take away 1 is 17. Okay, let's do the negatives. Now, when you substitute in a negative, it's wise to put it in brackets. This reminds us that we need to do negative 1 all squared, including the negative sign. So 2 times negative 1 all squared is positive 2. Take away 1 is 1. And let's put the negative 2 in. So negative 2 all squared is 4. 2 4s 8, take 1 is 7. And we can actually see the pattern here. This one here is going to be 17. Let's do one more. Complete the table of values for y equals 2x squared plus x, take away 3. Start again at 0. 0, 0, negative 3. Now let's put in 1. 2 plus 1 is 3, take 3 is 0. Putting in 2, I get 8 plus 2 is 10, take away 3 is 7. And then finally putting in the 3, I'm going to get 2 9s 18, 21, take 3 is 18. Okay, let's put the negatives in. Putting the negative 1 in here, negative 1 all squared is 1. So this is 2, take away 1 is 1, take away 3 is negative 2. And we can see that we're not going to get a pattern. In fact, we're still decreasing here. Let's put in negative 2. So that's going to be 8, take 2 is 6, take 3 is 3. And we're going to have to put in this one as well. So putting in negative 3, 2 times 9 is 18, take away 3 is 15, take away 3 is 12. And there it is. Now if we're given a table of values, then one thing we can do is find the rule. In a linear relationship, the first differences are the same. Now, this is what I mean by the first differences. Taking consecutive terms and subtracting the y values. So 7 take away 5 is 2, 9 take away 7 is 2, and 11 take away 9 is 2. So that's one way of telling that this is linear. This is also the gradient. And remember, this is the number that goes in front of the x. So when we form the rule, it's going to be y equals mx plus b. Here's our gradient here. And this number here is the y-intercept. All we have to do is go back to when x is 0, y would have been 3, and that will tell us what the y-intercept is. In a quadratic relationship, the second differences are the same. So let's have a look what that means. Here's the first differences. 5 take 2 is 3, 10 take 5 is 5, 17 take 10 is 7. Can you see the second differences? They're all 2. But we can find the rule for a quadratic relationship too. And a good trick is to include an extra row in the table for x squared. Then what you try and do is make y out of x squared or x terms or other numbers. Let's have a look. Here I've got 1, 2, 3, 4. Here's x squared, 1, 4, 9, 16. And here's y, 2, 5, 10, 17. So how is this row related to this one? How do I get from 1 to 2, and from 4 to 5, and from 9 to 10, and from 16 to 17? Can you see I just add 1? I'm going to do x squared plus 1. So here's our rule. Y is equal to x squared plus 1. Here's another one. Here I've got 1, 4, 9, 16, but with y I've got 4, 9, 16, 25. It's shifted along this way. So this here is not 1 squared, it's 2 squared. This one here is not 2 squared, it's 3 squared. And this one is 4 squared. So if I add 1 to the x and then square it, I've got my y. Here's the answer. Y is equal to x plus 1 all squared. How about this one? So I've got 0, 1, 4, 9. Here I've got 0, 2, 8, 18. What's happened? How have I got from the x squared to the y? This one's easy, isn't it? I've just doubled it. So y is equal to 2 lots of x squared. And then finally, the other thing that we can do is turn it upside down. So here I've got 0, 1, 4, 9. But here I've got 0, negative 1, negative 4, negative 9. I've just got negative x squared, and that's actually the rule. Okay, let's try a harder one. So in this case, it's not easy. It's not just a multiple of x squared. I don't just add 1 to it. I don't just shift it over. Let's have a look. I've got 1, 4, 9, 16 here. And here I've got 1, 5, 11, 19. Okay, so I've got x squared and I add 0. Then here I've got x squared but I add 1. Here I've got x squared but I add 2. Here I've got x squared but I add 3. Okay, so I'm kind of adding on x, but we're not quite right. Can you see that? So if I do x squared plus x, I'm going to get 2. X squared plus x, I'm going to get 6. X squared plus x, I'm going to get 12. What do you think it is? Hopefully you said x squared plus x minus 1. Let's check it with here. So putting the 4 in, I get 16 plus 4 is 20. Take 1 is 19. Okay, that brings us to the end of this first lesson. In our next lesson, we're going to look at parabolas.